In this video, you're going to learn how to identify, write, and name something called type 1 binary ionic compounds. Let's first talk about this term, type 1 binary ionic compound. So type 1 describes what kind of metal is in the compound. Binary describes the fact that there's only going to be two elements from the periodic table in this compound. Ionic means that the two elements are going to be ions. And then compound is telling us that they're two different elements, so they're not the same element. Remember, the same element is called a molecule. So these are two different elements. So let's say that we have the compound calcium chloride. So let's first talk about how we're going to identify this as a type 1 compound. It has everything to do with this metal here. The metal is a type 1 metal, calcium. Now, metals that are in these first two columns of the periodic table, aluminum from the third column, zinc, silver, and cadmium, those are always going to be considered type 1 compounds. So the fact that we have calcium, and if you're looking for calcium on the periodic table, it is right there, we go, right there. So that's why it's a type 1 compound. It's binary again because there's only two elements that are going to be part of the compound, and it's a compound because they're different elements. So once we know we have this ionic compound, what we want to do is draw a squiggly line to separate out the two words. So we're separating out calcium from chloride. And once we know that, what we're going to do is write the ions on either side of that squiggly line. So for calcium, that's Ca, we know it has a +2 charge because it's in the second column of the periodic table, because it's right there. And remember, everything in the second column of the periodic table has a +2 charge. As far as chloride goes, that's Cl, and we know that it has a -1 charge because it is in the seventh column of the periodic table. If you're having trouble finding it, it's actually right there. Now, once we know that information, the next thing we're going to do is actually circle these numbers, not the charges, just the numbers themselves, and then we're going to cross them over and make them subscripts. So Ca, and we're actually not going to write the 1. Those are pretty much the only subscripts that you don't write, are just the 1. And the Cl is going to have a subscript of 2. So calcium chloride is CaCl2. By the way, when you're circling these charges or the charge number, you need to be very careful not to circle the plus or the minus sign. You never want to carry those down as subscripts. Everything that's in a subscript is always going to be positive. So we're not going to circle the plus sign here, and we're not going to circle the negative sign. And again, remember, we did not write the 1 down here, even though that would have crossed down over, because we never write 1s in. We do write anything other than 1 in, though, because we had the 2 for calcium. We did put a 2 right here as a subscript. By the way, when we're looking at these charges, the only time we're not going to cross these charges down is if they're the same number. So if this was a 2 and this was a 2, we would actually just smush these two elements together. Or if this was a 1 and that was a 1, we would just smush them together. So an example of something like that, maybe something like calcium oxide. And again, calcium being a type 1 metal, we're drawing that squiggly line, and then we're writing out the ions for each side. which Ca has a +2 charge just like before, and oxygen has a -2 charge like before. And remember, from this point we need to circle the number but not the charge. And because those numbers are the same, we're just going to smush these two elements together without crossing anything over. So calcium oxide is actually CaO. The first example on your note sheet, I think, is sodium sulfide. So sodium sulfide, there we go. And if we're looking at the periodic table, which I've just added on here, you can see sodium is right here, which is in column 1. So because it's in column 1, that's going to be a type 1 binary compound, or type 1 compound. So I'm going to draw my squiggly, and that's Na, and we know it has a +1 charge because it's in the first column. And then sulfide, if you're looking for sulfur on the periodic table, it's right here, and that has a -2 charge. And then we're going to circle the numbers but not the charges, and then we're going to cross these over down as subscripts. So sodium sulfide is actually Na2S. And remember, we are not writing that 1 in, so make sure that you don't actually write the 1 in. In fact, I'm going to erase it right now. The next example on your sheet is one that we did before, which is calcium oxide. And remember, we knew calcium was a type 1 metal because it was in group number 2. So we would do that, and then Ca +2, O -2, circle the numbers. Those numbers are the same, so we're just going to push these two elements together without crossing anything over. Okay, further down on your note sheet, I actually gave you a compound formula. Anytime you're given a formula, the easiest way to figure out if it's a type 1 compound is look at the first element and see if it's a type 1 metal. So magnesium is right here, and remember that anything that's in group 1 or 2, or aluminum, zinc, cadmium, and silver, those are all type 1 compounds. So the fact that magnesium was right there tells us that this is a type 1 compound. And once we know it's a type 1 compound, the naming is really simple. All we need to do is name the metal. In this case, it's magnesium. And then we name the nonmetal as an ide. So Cl is right there, it's chlorine, but instead of chlorine, we're going to call it chloride. So MgCl2 is magnesium chloride. So if we're looking at Al2O3, aluminum is a type 1 metal, because remember, type 1 metals are going to appear in group 1, group 2, they're going to be either aluminum, zinc, cadmium, or silver. And the fact that aluminum is in that range, that's going to make this a type 1. So these are all type 1 metals. So that's a type 1 metal. And so this is going to be called aluminum. And then instead of oxygen, we're going to call this oxide, because binary ionic compounds always end in ide. So if it's binary, it's always going to end in ide. So now that you've watched this video, what I'm hoping is that you can look at a formula and figure out the name of it, or you can look at the name and figure out the formula of it. So kind of going in all directions there as far as the naming of type 1 binary ionic compounds goes.